It's March 23, 2021. A ship the size of a skyscraper is stuck sideways, wedged across one of the most important waterways on Earth. Behind it, a line of cargo ships is growing by the hour. Ahead of it, nothing is moving either. In the next 6 days, this single stuck ship will hold up over $9 billion of global trade every single day. So how does one ship stop the entire world's shipping? And why was it so hard to move? To understand why this mattered so much, you need to understand what the Suez Canal actually is. Opened in 1869, the Suez Canal connects the Mediterranean Sea to the Red Sea, cutting straight through Egypt. Without it, ships traveling between Europe and Asia would have to sail all the way around the southern tip of Africa, adding more than a week to the journey. By 2021, around 50 ships passed through this canal every single day. Together, they carried about 12% of all global trade. But here's the part most people don't realize. For long stretches, the canal is only wide enough for one ship at a time. Ships move through in convoys, taking turns. There's no lane to switch into, no way around. That single detail is what turned one stuck ship into a global crisis. This is the Ever Given, 400 meters long. For comparison, that's roughly the height of the Empire State Building just lying on its side. It can carry over 20,000 shipping containers at once, and on this trip, it was sailing from Malaysia to the Netherlands, owned by a Japanese company, operated by a Taiwanese shipping line, managed by a German firm and crewed by Indian sailors. One ship, 5 countries, before it even reaches its destination. On the morning of March 23rd, a sudden dust storm hit the canal. Winds reached speeds of up to 40 knots, cutting visibility and making the ship difficult to control. The Ever Given was moving faster than recommended for the canal at the time, and unlike the 2 ships ahead of it, it didn't have a tugboat escort guiding it through, though one wasn't required. The wind pushed the ship sideways, its bow jammed into one bank, its stern jammed into the other. It was now blocking the entire canal, in both directions at once. Within hours, ships on both ends of the canal began stacking up, unable to move forward or turn back. By the time the backlog peaked, more than 400 ships were waiting. Container ships, oil tankers, bulk carriers, even naval vessels, all stuck in place. Each day the canal stayed blocked, it held up an estimated $9 to $10 billion in global trade. Every single day. Fuel, food, electronics, car parts, all of it sitting motionless in the water. Some shipping companies made a different choice. A small number of vessels turned around entirely and rerouted around the southern tip of Africa, a detour that added 7 to 10 extra days of sailing. Here's the strange part. By the time those rerouted ships actually arrived, their total travel time ended up almost exactly the same as if they'd simply waited in line. There was no fast way out. Every option led through the same delay. So how do you move a stuck object the size of a skyscraper, wedged into sand on both sides? You can't just pull it. Engineers needed to attack the problem from multiple directions, all at once. First, dredging ships worked around the clock, vacuuming away roughly 27,000 tons of sand from beneath the ship's hull, digging deep enough to loosen its grip on the canal floor. At the same time, crews pumped out around 9,000 tons of the ship's own ballast water, making the vessel lighter and easier to shift. Then came the tugboats, more than a dozen of them, pulling from 3 different directions simultaneously, trying to walk the ship back toward the center of the canal. But even with all of that, there was one factor no engineer could control: the moon. The rescue teams timed their final push around a spring tide, the unusually high tide that occurs near a full moon. That extra few feet of water beneath the hull was enough to finally lift the ship free. On March 29th, 6 days after it first ran aground, the Ever Given was fully refloated, and the canal reopened that same night. Freeing the ship didn't immediately fix the problem. It took roughly another week of running the canal far beyond its normal capacity, well over 100 ships a day instead of the usual 50, just to clear the backlog that had built up. Then came the legal fallout. The Suez Canal Authority demanded compensation for the lost revenue and the cost of the rescue operation, and the ship itself was detained in Egypt for over 3 months while the dispute was resolved. But the more interesting response happened underground. Engineers identified the exact stretch of canal where the ship got stuck and began widening it by 40 meters and dredging it deeper, specifically to prevent this same failure from happening again. A system built for efficiency often has a hidden cost. It has no room for error. 50 ships a day, one lane, no detour, no backup. For decades, that worked perfectly fine. It only takes one ship in one moment of bad wind to reveal how little slack the system actually had. This is the same pattern you'll find behind almost every major system's failure. Not a system that was poorly designed, but a system that was optimized so tightly, there was never any room left to absorb a single mistake. The Suez Canal didn't fail because it was badly built. It failed because, for 6 days, there was no second path for the world's trade to take. If you found this interesting, there's a lot more hiding behind the everyday systems we never question. Subscribe if you want to keep pulling that thread.